today's goal of this lecture. Today I will see Equicontinuity and Arzela-Ascoli Theorem. This is today's goal of this lecture. This theorem actually very important for any competitive exam. We all of us know any subset of Rn is compact if and only if it is closed and bounded. This characterization is very important to check compactness in Rn. But is closed and bounded subset of Rn is compact? We all of us know any subset of Rn is compact if and only if it is closed and bounded. But is closed and bounded subset of Rn is always compact? The answer is no. A subset CXRn is compact if and only if it is closed plus bounded plus equicontinuous. Not only close bounded, when close bounded and equicontinuous, then the subset CXRn is compact, and such result is called as Arzela-Ascoli Theorem. This is very well-known theorem, and this theorem is very important in functional analysis, also in topology. At first, see, this is goal of today's lecture. At first, see what is the definition of equicontinuity. Definition of equicontinuity. Continuity means f is continuous at only unique point, and uniformly continuous means for all epsilon greater than 0 there exists delta greater than 0 such that for all xy belongs to x, d of xy less than delta imply rho of f of x comma f of y less than epsilon. This is the definition of uniform continuity. We all of us know. And equicontinuous, this is actually uniformly continuous. And the definition is for all epsilon greater than 0, there exists delta greater than 0 such that for all f, this is the family of the function such that for all xy belongs to x, d of xy less than delta imply rho of f of x comma f of y less than epsilon. And this is uniformly continuous because this is true for all function which is the and for all function is member of this set, and for all function when satisfy this relation, this is true for all epsilon greater than 0, there exists at least one delta such that for all x comma y belongs to x, d of xy less than delta imply rho of f of x f of y less than epsilon. If this relation satisfy, then this is called, such function is called all equicontinuous. I hope my all viewers have understood the difference between equicontinuous. Continuous means only one function, which is continuous means only at the point, unique point, and uniformly continuous means in the domain the function is uniform, one function, and this is function is uniformly continuous, and this is true for only one function. But equicontinuous means this is true for bunch of function. I hope my all viewers have understood. Well, x to the power n is not equicontinuous on the closed interval 0, 1. Why? Consider epsilon equal to half and consider the sequence an equal to 1 minus 1 over n. Then an minus 1, this value is 1 over n, and f of an minus f of 1, this value is 1 minus 1 over n to the power n minus 1, and this value is strictly greater than half where n is large number. So x to the power n is not equicontinuous on the interval 0, 1. If fn sequence of function is converges f uniformly on 0, 1, and if each fn is continuous, then that imply fn n equal to 1 to infinity is equicontinuous. Here each fn is continuous, we all of us know, but we all of us know fn which is equal to fn x equal to x to the power n, fn does not converges to f uniformly on the closed interval 0, 1. So by this theorem we can tell this is not equicontinuous. This is the relationship between equicontinuous and uniformly convergence. I hope my all viewers have understood it is clearly. If fn converges to f, if fn be the sequence of continuous function converges uniformly, then the collection of function f, collection called f, which the set fn, n belongs to natural number which is subset of C of xy, is equicontinuous. Okay. Next I will see what is the definition of uniformly bounded. What is the uniformly bounded? A collection of real valued function f on the set x is said to be uniformly bounded if the set fx such that x belongs to f and the function collection of function f belongs to this set is bounded on R. That means supremum of fx, where f belongs to this collection is all function, supremum value of all function is less than infinity, then this collection of function is called uniformly bounded function. I hope my all viewers have understood what is the uniformly bounded. Definition: the collection of function fn who is defined from x to r is said to be uniformly bounded if there exists a constant m belongs to r such that absolute value of fn x less than equal to m, and this is true for all n and for all x belongs to x. Here this m is always independent of x and m works for all value of x. This is always independent of x and this is works for all value of x. Then we can tell this collection of function is called uniformly bounded. As for collection of function is such type f defined from r to r such that f of x equal to alpha x, and this is true for all alpha belongs to -1 to 1. Then notice mod fx equal to mod alpha x, and this is equal to mod alpha times mod x. Here mx equal to since alpha lies between -1 to 1, so mx is less than equal to mod x. Okay, so notice here mx is less than equal to mod x. This is the value of mx and this is obviously bounded. This boundedness is pointwise but not uniformly, because here this value of m depends on point, but when uniformly bounded, then m works for all value of x. I hope my all viewers have understood what is the definition of uniformly bounded. Okay. OA. Next theorem, XB compact matrix space. If F is the totally bounded of Cx, then F is uniformly bounded and equicontinuous. That means given X is compact and this collection of F is totally bounded in Cx, then F is uniformly bounded and F is equicontinuous and F is equicontinuous. And we all of us know totally bounded means there exists epsilon net. A set A is totally bounded if for each epsilon greater than 0 there is a finite set x1, x2, xn contain M, so that A contain this epsilon net. That means if this is the set A, if this is the point x1, So there exists epsilon net containing the point x1. If this is the point x2, then there exists epsilon net containing the point x2. If this is the point x3, then there exists epsilon net containing the point x3. Is x4, if this is x4, then there exists epsilon net containing the point x4. That means there exists such type of epsilon net containing the point. So A contain this epsilon net, then we can tell the set A is totally bounded. And we all of us know if A set is totally bounded, then this is always imply boundedness. And any finite subset in Cx where Cx equal to those f who is defined from x to R, and f is continuous where x is compact metric space, then that imply if x is compact, and in Cx if f is continuous, that means f1, f2, fn, this finite set always equicontinuous. Here I will prove, given x is compact and totally bounded, then I will prove this collection of f is uniformly bounded and equicontinuous. And I have got any finite set in Cx always is Fi is equicontinuous. Okay? Let's, since given f is totally bounded, because given x is compact and totally bounded in Cx, that means it is bounded. That means supremum of x belongs to fx, fx belongs to infinity and this is true for all collection of f. And since f is totally bounded, this collection of f is totally bounded. That means let epsilon greater than 0, then there exists always epsilon net f1, f2, fn in which belongs to this collection of f, such that for any f belongs to this collection of f, since f is totally bounded, so there exists epsilon net. So norm of f minus f of I, this distance always would be less than epsilon for some I. And since given few minutes ago I have seen, if in Cx any finite subset continuous means f1, f2, fn are equicontinuous. Therefore, since f1, f2, fn is equicontinuous, there exists delta greater than 0 such that d of xy less than delta imply norm of fi x minus fi y less than epsilon by 3. Then mod fx minus fy, we can write this as less than equal to fx mod fx minus fi x plus fi x minus fi y plus fi y minus f of y. And I have got this value is less than epsilon by 3. So also this is less than, consider this is also less than epsilon over 3 for easy calculation. That means this value would be less than epsilon by 3. this is from this is also would be less than epsilon by 3. This is also less than epsilon by 3. And let this f belongs to f and d of xy less than delta. That imply, from this imply fx minus f of y less than epsilon. Therefore, this imply f is equicontinuous. So, if x is compact plus totally bounded in Cx, then that imply f is uniformly bounded. Also that imply this collection of f is equicontinuous. My next question, does every bounded sequence of function has a convergent subsequence? This answer is no. And by this approach, I will get the Arzela-Ascoli Theorem. What is the statement of Arzela-Ascoli Theorem? The statement is, the Arzela-Ascoli Theorem is, let xd be a compact matrix space and fn be a sequence of function such that this fn belongs to C of xr, which is pointwise bounded and equicontinuous. If this fn is pointwise bounded and equicontinuous, then fn is uniformly bounded and it contains a convergent subsequence. This is the Arzela-Ascoli Theorem. Means, if this f is a family of continuous function, on the closed interval AB and assume this collection is uniformly bounded, second, this collection is uniformly equicontinuous, on AB, then there exists a subsequence fnk of fn such that this fnk converges to f on the closed interval AB. That imply this fnk is uniformly convergent on the set AB. I hope my all viewers have understood what is the statement of Arzela-Ascoli Theorem. Today I will stop here. In my next video, I will discuss this topic and some example about this topic also elaborately. But at first I will hurry recommend you, please see this topic which I have defined today's video with pay attention. Then you will understand in next topic. Okay? OL.